our offices are close to Geneva, a very international environment, I want to say. And the purpose of the foundation is in general to save energy and reduce CO2 emission in industry by installing sustainable insulation systems. And I hope at the end of my presentation today, you will see that this is a big chance and that we have possibilities to create win-win situations. First of all, for industry, saving money, saving energy, as well as the environment. And of course, the more you insulate, the more happy are people who are working in this business. And we don't want to hide this win-win situation as well. And so this brings me to my second slide. What you see here is since 2009, and Fernando said that EIIF comprises, let's say, the leading companies in Europe, I would also say almost in the world. And we have contractors. Those are the companies fitting the insulation around pipes and vessels. And we have the large manufacturers producing insulation material. Okay, so this is the background. Where do we come from and why did we set up in 2009 a foundation like this? In general, the idea was that let's say, we from the insulation business, we experience every day walking through different kind of plants, from a refinery to a power station to a chemical plant, that we discover a lot of uninsulated pipe, valves, flanges, parts you typically find in industry. And we see that there is no money or no understanding. Why should we insulate this? And it's a little bit comparable to building a house and just don't put any window or door in it because this is more expensive and more complicated than just bricks. So just leave it a hole, and then when it is winter, you just, you push up the heating and you still stay warm. So this is a typical situation. And at that time, you also know the EU 2020 policy was started by the European Commission, and they started to work about this energy efficiency directive. And the goal was that greenhouse gas levels should be reduced by 20%. The renewables in the energy mix should be increased by 20%. And the most important for today, the energy consumption of the European Union should be reduced by 20%. And if you check on this picture here, you see that the greenhouse gas levels already 16.3% are achieved. So we're quite on track here. About roughly 13% of renewables are part of the energy mix in the European Union. But when it comes to the energy consumption, we are going to fail. And you see on the next slide, and I think I can show this to you with this arrow. You see, this is the scenario as it would have been if nothing would have been changed. So business as usual from 2007 on. Then status in 2009 is here, but we need to get down to here. And the latest the recent projections and estimations show that we will end up somewhere in here. So European Union is not on track when it comes to the 20% reduction of energy consumption. And we were hoping with EIIF, maybe we can support to this goal because we know with proper insulation, we can reduce energy consumption. So let me get one slide further. There is a quite, let's say there is a need. The transposition deadline for the Energy Efficiency Directive is 5th of June in 2014. So all national governments must have set up the measurements in place, how to reach these 2020 goals and how to become more energy efficient. And what I want to present you today is, let's say, the first and one of, I would say, easiest steps to reduce energy consumption and by doing that also reduce CO2 emission. So we have set up I'll just take this arrow out, okay. We've set up the EIIF in 2009 with a quite simple strategy on how to tackle these targets. So first of all, we said, okay, we need some proof. Of course, we know it, but no one else knows it. So we need some independent proof. So we commissioned Ecofis, the energy experts, doing a lot of research and work also for the European Commission to check about the savings potential of industrial insulation in EU27 industry, and I will present you the results of this study. We said, okay, we have a lot of best practice examples, so I will show you some of those. Then what we're doing now is building awareness. So if we know all this proof, if we know that we can contribute to the goals, we have to build awareness. So we need to do communication, and by doing coordination and networking, as we do now with Leonardo Energy, we hope to spread the word and the message that there is something to gain here. Actually, what we also found out in our study and in the research we did over the last 4 years, there is a big need for thermal energy auditing standard, I want to say. So something which is standardized, and this is a program, tip check, we called it, technical installation performance check, to identify in each plant what the best measures are related to insulation to save as much energy as possible. And in the end, that will always save also money. Okay. Of course, we needed to identify what's the reason for this large potential we find in industry. And we all know in building, a lot of people, or anyone I want to say, knows that insulation contributes to a better living climate, that it will reduce the heat cost and even the cooling if that is needed. But in industry, insulation is always treated and seen as a necessary evil. So you have to do it, but you don't want to. Let me put it that way. And many times we find that an industrial plant is planned, but the insulation was poorly forgotten, and so it has to be put in the budget at a later stage, and then minimum requirements can be done. But energy efficiency is just not a topic. We started to talk with the people we usually talk to from insulation, so the maintenance manager or project or facility manager, and telling him you might need to invest something between 100 to 200,000 euros, but you will get in return a lot of savings back, far more than the 100,000 euros, let me put it that way. But what does it mean for him? For him it means I have my maintenance budget, and now I should invest another 100,000 euros to improve the insulation and to make it more energy efficient. So first of all, I will be judged at the end of the year, and I have spent 100,000 euros more than were proposed in the budget for that running year. And I need all the money which is in for taking care of the maintenance. The nice thing is the energy costs, which will from then on be saved every year, they go down, but it will be the energy manager or the related energy, let's say, professional in the company who will get the reward because he reduced his energy consumption. So it split responsibilities between the two major budgets. One is maintenance, the other one is energy, and they need to be linked. And this is something which is crucial in our experience. We are very successful if we find a way to talk to both the energy manager and the maintenance manager, sometimes even the CFO, and to tell them the, let's say, very simple story on how you can save and reduce your costs if you insulate to energy efficient levels. So let me come to the results of this climate protection with rapid payback study. First of all, I want to explain how we did the calculation. And you can see here that you have the cost of the heat loss, you have the cost of the insulation, and if you merge, let's say, the cost of those two, you get this total cost curve, and this total cost curve clearly shows there is somewhere the cost-effective minimum. So the more you insulate, the higher your insulation investment goes, of course, but the lower your energy or heat loss will be. So what we did in this study, this is a value you can calculate. So we calculated the cost effectiveness of the insulation system for each case study, which was the basis of this study. And then we compared it to what is installed, what is, let's say, in the specification of the client, of the company. And then we said, okay, if the company would spend exactly the same amount as they spend today, they could get to here, and you see they would significantly reduce the heat loss, but still would pay the same. So this is a little bit of an artificial value, and I want to jump back to this cost effectiveness, because this is, let's say, the solid ground of this study. So whenever we talk about cost effectiveness or cost effective insulation, this is the value where the cost between heat loss and insulation investment get a minimum. Okay. So, next slide. What we found as an annual cost-effective savings potential in total, we found is 620 petajoules. And of course, what is 620 petajoules? Nobody knows. It's the energy consumption of the entire Dutch industry. Or it's equivalent to 10 million households. So the energy consumption of 10 million households. So quite something. In return, we could switch off 15 coal-fired power plants of 500 megawatts. And this is equal to the CO2 production or emissions of 18 million middle-class cars running around 13,000 kilometers per year. So here we really can contribute to this EU or wherever in the world we can significantly reduce energy consumption, and by doing that also reduce CO2 emissions. So what we found out in the study is that there are no limits. So the savings potential exists across all regions, sectors, equipment, and operating temperatures. There is not such a thing as, let's say, in chemical plants in Germany, you usually don't find a potential. That's not true. You find it everywhere. The question is, what is the best way to tap this potential? And therefore you need well-educated and qualified specialists using, I want to say, the tip check standard, which is really a standardized way on evaluating what makes sense, what might be too costly or insufficient in another way. And sometimes you can't insulate because of whatever reason, maybe not enough space, or it's an old pump, and if you in-house it with some insulation material, it will get too hot, and then immediately the pump will break. So what we also found out is that the uninsulated and damaged parts offer the attractive payback times. So payback times usually are less than 1 year. So in the year of your investment, if you go back to this first split responsibility slide, if this maintenance manager would invest 100,000 euros plus to increase the energy efficiency, these 100,000 euros will be paid back in the same year. So the money will be given back to the company in the year when they do the investment. And I will show you some extra examples. Why is it like this? What we found out, and again, let me just draw this here. You see that the initially required investment for the insulation, which is quite a cheap measurement compared to others, compared to the annual savings from reduced heat loss, have a very, very nice, a very, very nice balance between. So you save much more than you need to invest first. It is different when it comes to currently insulated surfaces. So the investment here becomes much higher because you have to take off the old insulation system and then put on the new one. And because there was insulation already, the reductions are by far lower than compared to a bare pipe, for instance. So there you have a different scale. So what we recommend in general is to start with the uninsulated and heavily damaged parts. So when we talk now about these 460 petajoules, and I don't want to confuse you too much, but in this study we had those two values. So we said bare or damaged parts, and then the other cost-effective thing you can do is increase the existing insulation system to an energy efficient or the cost-effective level. So when we talk about those 460 petajoules, this is just the potential we would gain if we would just simply insulate anything what is not insulated today or what is covered with such damaged insulation that you can count it almost like uninsulated. This doesn't mean that we would increase, let's say, a pipe which has 40 millimeters of whatever material around, and you would increase this to 80 millimeters. Of course, you would get some savings, but these are the rest, the 25%, which is left over. So let's say the 460 petajoule, the 75% of the entire savings potential of 620, you will gain and you will tap if you simply insulate uninsulated parts or heavily damaged parts. We calculated that the one-time investment to do this is about 900 million euros. The high annual savings, and this was a figure we can't believe ourselves, and we checked it double times, and the Americans did a similar study and they come to a similar result for America. The annual savings is about 3.5 billion euros. So for, let's say 900 million euros is not nothing, but if you check on the high annual savings, there's quite something in. But I will show you more concrete examples a little bit later on. So from the theory, and to explain why is it so important to think about the uninsulated parts, and why should those be the first parts to take care of, I want to present you this table with the comparison of the different situations. So what you find here is the heat losses in watts per meter for a bare pipe. In this line, we say, okay, that is already insulated, only with 25 millimeters, but it is already insulated. And you can see that even with this small insulation, it's doing already a proper good job. So it reduces down the heat losses quite significantly. Now the next value we calculated, let's say the cost effectiveness, is 80 millimeter. And then you see, okay, compared to this value, you can reduce it down to 92 to 111 or 227 from 3,600 watts per meter. If you now compare between bare and 80 millimeter and 25 and 80 millimeter, you find that in the end, insulating a bare pipe saves 20 times more than increasing insulation on already insulated parts. So this is the background why we really try to convince industry not to insulate, let's say, just the pipes they did in the past, and to forget about those parts which were usually not insulated, like connections or like valves, as you see in this picture, or rooftops or whatever. So to think first, let's just simply check what is insulated and what is not insulated, and why is it not insulated, and is there a chance to do this? Because there we get the most interesting savings. So approximately, if you take the average, approximately 20 times higher just to compare it. And this is crucial talking to maintenance managers, because there is a habit, and it's throughout, I would say, the world, not to insulate valves, for instance. And we think that is a big potential left aside, which can be tapped quite easily. Okay, so just to give you a latest example from Singapore, where we did a tip check in a refinery, and you see the conditions for Singapore, 200 Celsius degrees, ambient temperature quite high, 27, wind velocity, and so on. And you find here for an 8-inch, 10-inch, 12-inch insulation thickness specified with 80 millimeters, the energy savings, the CO2 emission reduction, and the total savings in euros per year were about 800 euros. And using this just as a ballpark figure, you can ask yourself, going back from this presentation maybe, how many uninsulated parts do we have in our plant? And then you multiply this number. Don't do it with the 800 euros. You can do it, but it's better to have a first guess by a tip check engineer first. But then coming from there, it's rather easy to calculate your savings in money. So let's say if you identify about 500 parts, let's say 100 valves, 150 connections, some pipe length where the insulation is so heavily damaged that you have to reinstall it again, you come up to something like 500 parts. You multiply it with the savings potential estimated by the tip check engineer, and you get immediately an idea what your annual savings will be. So let's say for this calculated case, 400,000 euros. So if you would invest in this year 400,000 euros in insulation, and you can insulate a lot for that, you would have a payback time of 1 year, and you would have increased your energy efficiency significantly. Okay, I will show you later on a nice example of that, which we did in the south of France in a chemical plant. Just to recall again, this tip check standard, technical insulation performance check, how we called it, it's a registered trademark because we really want to take care that the quality is high. It's first of all a standardized way of doing thermal energy audits. So if you ask one of the more than 50 certified tip check engineers to do it, they will all do it the same way and standardized to offer you a very efficient and qualified service. To be qualified, we train our tip check engineers for 1 week, and they get a software tool which is also standardized and developed by our foundation, which calculates the energy savings, CO2 emissions, and of course, dependent on the installation price and energy price, also cost reduction possibilities. We have minimum requirements, so an engineer who wants to become a certified tip check engineer has to have 4 years experience, usually also a university degree in engineering. The ability, of course, to calculate and design industrial insulation systems. His company has to be a member in EIIF. This is for quality assurance reasons. We do random checks so that we really want to take care that the quality is high. And of course, they have to pass the test at the end of the year, but this is not enough. They need to refresh after 3 years or every 3 years their knowledge and come to a free refreshment course training. This is also something where we want to improve the program steadily. So what do we find if you do a tip check on site? And I promised to give you some real examples from reality. So this is, let's say, unfortunately, something we find very often in industrial plants when it comes to cold insulation, and valves are not insulated. The next one is even better. So the electricity here had to be covered very professionally by this plastic thing, because there's water dropping down from the ice which is built here because the insulation is not doing a proper job, or because maintenance didn't take care of this. So this is something you find in Europe, and this is something which we find quite often, maybe not as nice as here, let me put it that way, but it makes sense to check if you have ice somewhere on your pipes, on your valves and flanges. This is actually something where you lose a lot of energy. Ice has got a much better insulation effect than metal, but of course a worse insulation effect, or much worse insulation effect compared to any insulation material. This is also typical, so that's what I said before. The cladding, for whatever reason, it's not there anymore, and you can think or you can imagine this looks like mineral wool wired mats. They're out there in the rain, they get wet, and of course they lose their insulation effect, and you get even more problems with corrosion and insulation and so on. But this is typical. This is polyurethane, the same thing. For whatever reason, what happened here, we don't know, but it just stays like this. So this is an open window in the industrial plant. This is something easy to be fixed, and it will help to save energy significantly. This is also something what we find very often. So people just don't care, and they walk over the cladding, and they don't think about what this has as an effect on the insulation underneath. So there will be water ingress here and there. The same thing starts again. Insulation gets wet. It starts to lose its insulation effect. It causes problems like corrosion and insulation. And this is really something we need to build awareness with your people to treat insulation in a professional way. Then it will do a very good job. If you do it like this, it loses energy and it will cause some problems here and there. Not the insulation, of course, but the broken system in itself. Okay, let me give you some tip check examples for the last 10 minutes. So we did a tip check in a chemical plant in France. Let me give you also some key facts that you get an imagination of how much work it is. So this was one employee equipped with a thermographic camera. It took him about 2 weeks on site to identify the spots bearing the largest potential. He needed 400 pictures to do this. Of course, they are also used in his audit report at the end. And the key findings, and this is something we experience in almost every tip check we do. So first of all, safety. We always find surface temperatures above the allowed 50, 60 degrees Celsius in areas where people can easily reach. Financially, money savings due to reduced energy loss. And let me go back to my first example. Think of a building with no windows. If you put whatever into these holes where usually windows are in, it could be a newspaper, you will start to save energy. But of course, if you use a proper window, you will save a lot. So there's always something to find in any plant. And then, of course, energy efficiency, energy heat loss, that is the target. So for this chemical plant in France, we found these valves, as you can see here. Maybe the figures are too small on your screen. So this is uninsulated, and the thermographic image shows here that its temperatures above 280 degrees Celsius, and you can very nicely see how hot it is where the insulation is missing. Yeah, you see here, and how good it is insulated where the insulation is well in place. Okay, the insulation solution, and this is also something which is typical for industrial insulation. We're not talking about rocket science. It's usually simple solutions. So here it was the installment of mattress insulation, and by doing this, we could assure that the surface temperatures were below 50 degrees Celsius, so no more safety problem. Astonishing was that we found about 30 similar valves, and they all were identified and insulated. And this is what I said before. It used to be like that yeah, we do insulate pipes, but we don't insulate valves. This is something we hear very often. Okay, what was even better from the financial and energy savings point of view, but let's say no safety issue, and this is why it comes second. We found storage tanks, 35 of them, and they had no insulation underneath their roof. And so what we found here is that an unnecessary energy loss per year of about 12,000 megawatt hours was appearing here. Together with the valves, you can see the savings are quite smaller than that. If you compare this is for one tank and this is for one valve. So the savings potential identified was about 12,600 megawatts, and the total annual financial saving potential was about €500,000. The investment for this was €10,000 for the tip check. The installation installment and material costs, roughly €90,000. Of course, these figures are rounded. The total investment, approximately €100,000. So in this case, and this is due to these rooftops, and let me again go back to building. If you think about a building without insulation underneath the roof, you can imagine how large the savings are if you do this. Another very important example is the refinery in Italy. So they had to rebuild a new tower, and the client was asking for a much better energy efficient system, but also with a better fire protection, because that was the reason why they had to rebuild it. It was destroyed by a fire before. And by doubling the insulation thickness here and in places where there was not enough space, using material which doesn't need the thickness but has a much better insulation characteristic, energy savings were about 1 million kilowatt hours. and the financial savings here in this were 75,000 euros. The payback time here was, we say between 1 and 3 years. The reason behind that is that if only for energy efficiency the installation would have been improved, it would have been 1 year, but because of higher costs for the fire protection material in this project, it was 3 years. So if you consider 75,000 euros per year annual savings and a payback time of 1 year, if the material would say is a standard material, so the investment would be 75,000 euros, you would think, okay, this refinery did all the towers after this experience. But of course they didn't, because what they earn with one tower like this per day is 250,000 euros. So you can forget about the payback time if you stop a refinery to improve the installation system. So this is something what we teach our tip-check engineers. This is something why it is crucial to work in close collaboration with those people who run the plant. And this is what we do in the beginning. We check out what is the situation on site. What is this part and that part offering, and how can we tackle or how can we tap the potential best? This is absolutely crucial. And this is why we think a good education is also necessary. An example from Germany, actually we didn't offer a tip check here because it was such an easy example that we not even needed a thermographic camera to do it. The only thing which was needed was to go there in I try to get this arrow down, but it doesn't want to. Okay, anyway, then we forget about it. So this elevator, which is this this square thing going up vertically to the top of the tower. Let me just try again if I can use it again. Come on. Okay, I'm sorry. Maybe I go back and forth again. Maybe then it's going to work. Yeah, okay. Let me check this. Okay, that was a good idea. Okay, so this elevator was gluing red on a foggy day. And because it was gluing red, we thought, okay, let's give it a check and see if there's some insulation material underneath, and if, which one. And of course it was blank. So there was no insulation material inside. And by just fitting a simple insulation material, the investment was about 13,000 euros to do this. Energy savings, 1 million megawatt hours per year. Financial savings, about 50,000 euros. So the payback time was 3 months. So this was immediately done by this company in Germany. And at the end, it was not that they just saved energy only. The material, the asphalt, is in a much better viscosity when it reaches the top. And so it can be handled much better, and the quality of the asphalt also increased. So classical, what I said in the beginning, classical win-win situation. The insulation company was happy. They had to do something for 13,000 euros. The environment is very happy because of the energy savings, and the client is, let's say, the most happier one, is the happiest one, because he's saving energy, he's contributing to a better climate or environment, and he has improved the product quality and reduced his costs. Okay, so if you need to tip check your savings potential, this is something very interesting for anyone, and of course, we highly recommend this. And let me go through the last minute to some typically asked questions before a tip check to give you some answers on that. So how does a tip check contribute to our sustainability program? I think I can go very quickly through this. I explained that before. So besides the energy savings potential, I think it is crucial that insulation offers significant life cycle cost reduction potentials. Then why should we start to insulate uninsulated fitting, walls, flanges, etc.? I hope you don't have these questions anymore after this presentation, so let's go quickly through this. A typically asked question is, how do we approach this energy efficiency program? So our certified tip check engineers usually come to you, they will analyze the present situation, and then they come up with a roadmap to energy savings for you, and of course they will adapt it to any program you have concerning energy reductions. What steps need to be taken in order to implement the roadmap to energy savings? Well, of course, we need to check with all stakeholders, including production, plan, asset integrity, site maintenance, mechanical energy management, and so on, to define the correct implementation and execution strategy for your facility. Sorry. Then how long will it take? Of course, this is very much dependent on the size of the project. If you check on this elevator, it's much faster than on the refinery tower, of course. A measurement, as we did it in this chemical plant in France, goes rather quickly. What is the impact on daily operations is one of the most important questions, of course. There we really try in close cooperation to mitigate disruption, of course. There's always something we can do with non-intrusive effects, so it can be done where operational units are in fully production. But of course, sometimes we also identify parts where you need to do it at the next turnaround. So what are the technical and operational challenges we'll have to deal with? So of course, there is a big question, but easy solutions for that. How to detect and control leaks from valves and flanges if they are insulated. How to ensure mechanical integrity. For instance, if you put insulation around, because of the heat inside, the bolts may tension. So this is relaxing the system. And again, the question of leaks could come up. So that needs to be identified before. What are mechanical design temperature limits of the newly insulated parts? Of course, how to avoid water ingress. I showed you the pictures of the broken cladding before. How to ensure mechanical rigidity of insulation covers. So these topics are usually addressed, and of course, this is a cooperation project with your specialists. What is expected from everyone working on site? This is our dream, let's put it that way. A careful and professional handling of insulated systems in order to ensure energy savings, so please don't dance on claddings. What are the advantages for associates? An even safer working environment, of course, better working conditions, and personal contribution to a cleaner environment, so everyone can do something here. So as a summary, and I'm 2 minutes delayed, the savings potential of industrial insulation is, I guess you can expect what's coming here, large. The savings potential is highly cost attractive, as we showed, and the savings potential can be tapped right today. So we can start right today. We just need to come to your plant and to do a tip check, and the tip check engineers we provide will be very happy to do this. So thank you very much for your attention, and I think, Fernando, we said we should have about 20 minutes time for question and answers.
Okay, great. Thank you very much, Andreas, for this comprehensive presentation. We are happy to receive such kind of sessions with a very clear explanation on life cycle costs, which is always the issue with energy efficiency measures. So this is a great example on how investment decisions should consider life cycle operational costs. So thank you for this contribution. This is definitely great. We have some questions coming, so please, for the audience, feel free to submit your questions through the Q&A window, which is on top in the middle of the screen, and we will be processing one by one. In the meanwhile, I think we are already receiving some. We had during the presentation a question relative to slide number 17, based on relative to what's the pipe temperature in slide 17. So let's maybe jump very quickly to this slide and take care of this. One moment. Yes. So here the question is what was the temperature considered in this case? Well, I don't know whether we do have this information at at the moment?
Yeah,
Andreas?
well, of course we had the information for this when we did this calculation. It was, but actually I don't recall if it was 200 or 300 degrees, something like that, the medium temperature in that case.
Relative to this slide, I will take advantage and I will ask a question.
Yeah.
Is insulation for 80 millimeters 3 times more expensive than the insulation for 25 millimeters?
No. Let's say one part of the insulation price is the work, and that is quite a decisive part. And it takes the same time to put 80 millimeters around the pipe than 25 millimeters. So the price is not increasing by millimeter. There is a price jump if, let's say, a second layer of insulation material has to be put. So let's say if 160 millimeters were necessary and you would put 2 times the insulation material with 80 millimeters around the pipe, then there would be a slight price jump for the work to do. But it makes not a very big difference. Of course, the material becomes a bit more expensive, but the most or one of the cost effects is the work that needs to be done, and this is exactly the same work. So that's much lower than 3 times what you need for 25. So let's say from the work perspective, you pay exactly the same amount. From the material perspective, there will be slightly increase. But in general, that's something we can really say. The more you insulate, the work itself doesn't increase in the same way.
Okay, good. So in this case, the user could consider very well going to the optimal
Exactly.
insulation.
Yeah.
Will not increase dramatically the cost. Okay, good. We have a question relative to what work is doing your foundation with the European Union in order to raise awareness, increase incentives for insulation and put directives, legislation in place. I had a question relative to Eco-Design Directive, whether this directive is addressing this field of actions. Thank you.
Yeah, so, well, first of all, what we do is we work in this sector forum, energy management. This is actually how we made the connection to Leonardo Energy. And we try to help here to promote ISO 50001 as an energy management standard. And this is, of course, connected to our tip check program. So if a company integrates an energy management standard, they need to do energy audits. And thermal energy audits, let's say, is one of the first and easiest steps you can do to increase your energy efficiency. So this is where we support and contribute this working group. We're actually discussing at the moment to set up our own roadmap to 2020 for EIIF. And one of the major topics there is how can we give regulatory advice or do advocacy in Brussels for the EU Commission and help them to, there's always the question, competitiveness. How can we keep the European industry competitive, but still make industry save energy and reduce their emission? And we think if you do the right thing, so you do something which increases your energy efficiency, which is not too costly, and by increasing your energy efficiency is paying back itself rather quickly, this is a competitive advantage. It's as simple as that. And insulation is one of these best available techniques which you can use and which fit in here. So we are in correspondence. We talk to like Paula Rey Garcia from the DG Energy, and we are actually now setting up a roadmap for EIIF. What can we do to help better and build awareness here? And of course, the idea was from the beginning, but we first had to establish the tip check program. So this is the solution, and we had to develop this proof with an independent organization to make or to have tools in our hands rather than just telling stories and to help industries as we do right today to reduce their energy consumption.
Very interesting. Complementary question related to the work with contractors and contract managers.
I would, well, what we do is the contracting companies, or let's say manufacturers and contractors who decide we become an EIIF member, well, they do this, and for their employees we offer the training, so they can send their engineers to our training courses so that they can become TIPCHEC engineers. And we are also open for companies, let's say like Shell or ExxonMobil or whomever, who would need a certified TIPCHEC engineers and who have their own installation specialists on site to join these trainings and to learn what is in for them to gain. There's one thing which is really crucial, which we always tell them in advance. If you want to calculate the most cost-effective system, you need to know the installation price, because this is the basis for the calculation. And therefore, it is a very close relationship between cost for the investment, cost for the heat loss. This is what we showed before. But we are very open for any company to join us and to find out what is in for them.
Okay, good. There is another question. So, relative to the energy savings shown are cumulative, or this is just the payback, the annual savings?
Well, what we show in this presentation is always the annual savings. So we calculate simple paybacks. So let's say the investment for the installation system is 100,000 euros. The annual savings, because of the reduced heat losses, is 100,000 euros. So it's a payback time of 1 year, and if this plant is running for 15 years, they will save in the end 15 times 100,000 euros minus the investment. So 14 times 100,000 euros.
Okay, good. I have another question. How do companies go about booking a TIPCHEC engineer in European countries? What assurances can be given that they are completely independent? I'm concerned that contractors in the UK will see TIPCHEC as allied so closely with TICA that it loses credibility.
Yeah, we don't have these difficulties, let's say, in our first examples. First of all, it's the typical situation. If you go to an auditor, you need to trust him that he's doing a good job. And of course, you could think, let's say, a certified TIPCHEC engineer from an installation company goes into the plant, and now he needs to identify parts which need to be insulated, and you might fear that he is selling you now his service and as much insulation material as possible. Experience is totally different, because if you want to carry out the TIPCHEC, you need to do it in really close cooperation with those people who live the plant, who know the plant, because otherwise you can't do a good audit. And very often we find, let's say, especially when we go for the uninsulated parts, that the client has a specification in place. Maybe it is not the latest standard. Maybe it's not the best cost-effective system. But let's say cost-effective would be 80 millimeters, and in his specification he's recommending 60 millimeters. So what we usually do here is really in close cooperation find a very educated solution. So let's say there is 3 kilometers of a pipe, and there are 20 valves in between which are not insulated. So what we would recommend here is use the client specification and insulate them with an easy solution using the insulation material and thickness which is in the client specification, so 60 millimeters. Because it makes no sense to have the pipe insulated with 60 millimeters and then the valves with 80 millimeters, for instance, because we calculated in our program to be the most cost-effective solution. So this is the way how the TIPCHEC process runs. And we have not one example so far where a client came up to EIIF to tell us, I don't trust the TIPCHEC engineer. What we had already was the case that a client was so surprised that calculating cost effectiveness doubled, like in the refinery example, doubled the insulation thickness he was using over the past, let me say, 30 years. And that made him feel uncomfortable. So what the tip check engineer offered to him is, please go to EIIF, let them make the calculation and see what the result will be. And as we got the same data to calculate, we came up with the same results. You need to double your insulation thickness if you want to be cost effective. And we could explain to him why it is like that. If you look on how energy prices have increased in the last years, if you check on energy efficiency in itself, related costs to CO2, we don't know how energy prices are going to increase in the next years. It is very easy to understand that with a low-level insulation specified 30 years ago, compared to today, if you just see how the price for oil increased within the last 30 years, it's easy to understand that from a cost-effective point of view, insulation thicknesses increase or insulation quality has to increase. So a clear answer to that, it's a typical relation between client and customer, between client and service provider. Of course, you have to trust each other, and we try as EIIF to do our best that the tip check engineers are really highly qualified and that they do a good survey. Secondly, we do random checks. So we tell a tip check engineer, we will visit you on your next tip check or on your current tip check, and we will double check the calculations you do. And any client has to any time the chance to address to EIIF and tell us, I have a tip check engineer, it's Mr. So-and-so, and he did these calculations for us. We think they're rather high. Can you please check if this is really cost effective for us or if this is the best solution? And we will be happy to do this.
Okay, good. Good to know that. So next question is about the limitations of the usual insulation materials and systems.
Well, this is a very general question for a very specified special request, let's say. Gregory, what limitations do you mean? By the highest temperature for it or the largest thickness to be installed?
Okay, so let's maybe allow Gregory some additional time to specify a bit more his question. In the meanwhile, let's go for the next one. So in practice, how easy is to insulate valves? And does it require special training when compared to insulation in straight pipes?
Yeah, it is more complicated, and you know what we were talking about before. Maybe you need some extra solution to identify leaks underneath insulation if they would appear, but there are solutions in place. It's not, let's say, it's not as easy as, and of course it takes more time, and sometimes you need tailor-made solutions on how to fit it around the flange or the extra shape. But a good insulation company should be able to provide this.
Okay, good. So next, well, it's rather probably housekeeping question, but there is probably as well something for you as foundation. So can we receive a proper and complete presentation for stakeholders? On the one side, you have, I'm putting here the link to the Leonardo Energy webpage where you will find today's presentation and the recording of this session, including questions and answers. Additionally, if you need additional materials from the foundation, you can direct your request to Andreas, whose email address is indicated on the right side in the middle. So you will find there speakers, contacts, and references. Andreas, would you like to complete?
Yeah, or you of course at any time you're more than welcome to address directly to us, and we will be very happy to make a tailor-made presentation for your needs. not at all a problem. If you're an insulation company, please just contact us. If you're any other company, we will always find a way how we can find the best way to support you with that. And maybe have a look on eIF.org, our website, where we provide also a lot of information. Yeah, but we're here to service you. Let's put it that way.
Very good. Next question is relative to recommending any product concretely for thermal imaging. Well, I'm afraid this is not the purpose of this webinar, and probably neither the purpose of your foundation to promote any particular brand. So I'm afraid this question has no particular answer in this.
Well, but Fernando, there's one thing to add. We have thermal imaging is part of this tip check training. So we do some exercises with different kind of cameras. So we show the advantages, but also the difficulties and things you need to know if you use thermal imaging and these cameras, because you can do a lot of mistakes there. So what we really recommend is for our tip check engineers to get a level 1 certificate on thermographic imaging, let's say as a good advice, and then required a qualification, additional qualification for a tip check engineer. And then in these trainings you learn all about the technology and the quality of different cameras and prices for it. But this is not cheap. This is by far more expensive than the tip check training we do, and as you said, Fernando, this would be interesting and nice for a second webinar by a thermographic imaging trainer who can tell you all the, let's say, delicate things, but it has great advantages. So we recommend to use it if you're qualified.
Okay, good, noted. So we will definitely think about carrying out such a webinar. A housekeeping question, so whether we are recording this question, so it's the case, so just be sure that this will be published. Another question, a problem is often space around equipment, so does it exist insulation with a higher degree of insulation that is cost effective?
Yeah, that is a very good question, because this is a typical challenge. And we have set up the tip check calculator, as we call it. It's the software to calculate the savings. And we can, in this calculation tool, we can see savings for, that can be defined by the engineer for every 5 or 10 millimeters increase of insulation thickness. So there could, or if, let's say, what we experience most of the time, the calculation says the best system here would be 80 millimeters, but we find space for 60 millimeters. And what we do then, most of the time, because that's the easiest solution, okay, in this particular part, we just install 60 millimeters of the same insulation material as we have on the other pipes with 80 millimeters, because there's just not more space than that. This is also most of the times the cheap, or let's say the most cost-attractive solution. Of course, there are new materials like aerogels and so on, which have a much higher insulation value, let's say, with less space than, for instance, mineral wool or polyurethanes. And that can be used, actually in this refinery example, whenever it was not possible to double the insulation thickness, for instance, aerogels were being used. So not in any part, but at some parts. So this is again why a tip check engineer needs to know, to have 4 years experience and very well to know what he's talking about. So that for those parts we also can offer a good solution. Of course, aerogels are much more expensive than let's say a standard mineral wool. So payback times get longer, of course, the more specialized products you need. This is a very simple equation and a very simple truth. So, hope to answer the question with that.
Okay, thank you very much. Next question, can you describe a bit more what you're seeing in the field, specifically the facilities and equipment in which you're observing and validating the greatest opportunity to upgrade insulation cost effectively?
Well, so for the equipment, let's say in general, it's the typical parts which are usually not insulated, like valves, flanges, connections, and so on. As I said before, there are no limits by regions. There are not limits by plants. You know, you find it in breweries, you find it in refineries, you find it in chemical plants. Let me put it very simple. Wherever you have pipes to transport whatsoever, if it's steam, if it's gas, if it's whatever liquid, it can even be chocolate, or as we have in one example, the asphalt. Whenever you have pipes and vessels and there is some insulation around it and some parts are not insulated because you have temperatures which are higher or lower than ambient temperature, there is something to gain. And there you really need to talk to an expert. Let's say if you would be the energy manager of a brewery, in the brewery you have very different parts where let me take a very stupid example, but maybe it's a good one. Let's say for the bottle washer, where you have high temperatures for the water to clean the bottles. Of course, it makes sense to check if the insulation around is sustainable, is energy efficient, is cost effective, or if there is something to gain. And you know the other examples we had. So we highly recommend to get in contact with a specialist, let's say with a tip check engineer, and see where and how you can find spots which offer you really good savings potentials. And this is the job of a tip check engineer, actually. And if he would go back home to tell you there's nothing we can do for you because you're so well insulated here, well, fantastic. So then you know you're doing a good job and you're not losing a hell of a money every day.
Thank you. Okay, so probably last question. We are coming back on Gregory's question. What are the limitations of the usual insulation materials? And then specifying these can be thermal. Are there some type of parts concerned? So, well, I don't know whether this gives you additional clues for an answer.
Yeah, I have to be honest, I have a little bit of a difficulty with this question. So what are the limitations of the usual insulation material systems? Can be thermal type of parts. I'm not totally sure, Gregory, what your question is. Maybe you just give me a call after this presentation and we can try to really find out what your question is by talking, let's say, face-to-face together, because I don't really understand what to answer here. I don't understand your question. That's as simple as that.
Okay.
Or maybe I just get an idea. Maybe this is something. If the question is, can you insulate everything? The clear answer is no. So sometimes there is a good reason why things stay uninsulated. And this is what I said before. So the tip check engineer, in close cooperation with the maintenance manager on the plant or whomever who is responsible for that, needs to check if there is a technical issue. Why, for instance, this is a typical example which we find quite often. There's a pump running, and this pump is, let's say, 10 years old, but it's still doing quite a proper job. But if you would in-house it, even having a surface temperature of 150 degrees, but if you would put some insulation material around, of course, inside it would get so hot that I don't want to say explode, but the pump will, in let's say, one day stop to work because it just got overheated. So we don't in general say anything that is uninsulated can be insulated. What we say in general, anything that is uninsulated should be checked and it should be evaluated if it can be insulated, and if so, what would that be in costs and how far and how fast would it pay back the investment for being insulated. So this is really something where we offer a tailor-made service for each part.
Good, thank you. So I think we reached the end of today's webinar. thank you very much to the audience for your interest and active participation. Thank you, of course, Andreas, for this very interesting speech and, increasing awareness about the high relevance of operational costs. So this is always very welcome. We will close here the session, and Andreas, I give you the floor for the final words. Thank you.
Thank you very much, Fernando. This is the first time that I did such a technology-based webinar without any technical problems. So thanks very much. Great. And thanks very much to the audience for joining us today. And please feel free, you find us on eiif.org, eiif.org. If you click on contact, you find my telephone number and contact details directly, as